Yes, thank you. You see my slides?
Yes.
So welcome everybody. Today we're going to talk about the ARC6 version of the computing element produced by the Nordic collaboration. And then three of us going to be presenting various aspects of the ARC6. It's myself, Balazs Konya, Florido Pavanelli, Andriy Sanikov. Plus we're going to have a couple of experts available for the question and answer parts. So the program is structured this way. As we're going on with the time, the details will be more and more heavy technical. So I will start with an overview, a high-level bird's eye overview of an ARC6. Then I will give you a very quick introduction how to decode the things in 6 steps. Then Florido will go over and introduce the changes from ARC5 CE to ARC6. And then we're going to do very technical things about 2 new very important features areas of an ARC6 CE, which were not present in ARC5, but makes the life of the sysadmins way much better. This is the ARCCTL sysadmin toolbox, and then the resource usage tracking feature, accounting capabilities of ARC6. And then we will be available for questions. Yeah, so ARC6. 6 is an interesting number, and this just realized yesterday when I was writing the slides that 6 is coming up every time when we're talking about ARC6. So we had the release on the 6th of June, almost. And then this was a follow-up after the 6th release candidates. And then the work started in 2016. And today, on 6th of July, when we talk, giving a seminar on ARC6 for the EGI users. So 6 is everywhere, and you will see 6 appearing in several places during this presentation. What is an ARC6? Those who haven't seen ARC before, we call it a traditional computing element. Computing element is something which sits on top of a cluster, usually aggregated by a batch system, and it offers you a gateway functionality to the computing cluster. And ARC is coming from the Nordic collaboration, and it's one of those old traditional classic CEs which are still available. When you ask system administrators what is ARC, they say it's boring, it's well known, it's been around for a longer time than a decade, and they are true. So if you visualize what is an ARC, you could say that an ARC6 is like a good old reliable Nordic product, like this old Volvo. It takes you to the place where you want to go, but nothing is fancy there. But if you look into the details a little bit more, then I hope that by the end of this webinar, you will have the feeling that when you're driving an ARC6, you're basically sitting in this car. So old CEs don't die, they just get faster and more reliable. With this car example, I just wanted to tell you, so it's not a spaceship, it's nothing revolutionary new. It's a good, reliable technology which does the job of injecting jobs and data into a computing cluster and managing them for various communities. It's a little bit of history on this slide. We used to make a joke that ARC has been around, or the Nordic has been around 5 years before BC. And BC in this case means that before the clouds appeared on the surface. So the collaboration was born in 2001. It's recounted like 5 years before clouds. But the take-home message from this slide is that this is a product which has been around for a very long time, and it has a demonstrated long-term support by the Nordic collaboration, and we have a ability to continuously renew and adapt to the ever-changing IT infrastructure and technologies. So if you go for ARC6 or ARC, you will get a support sort of guaranteed for the coming years. Where ARC is used, it's a common choice mostly in Europe, but we also get deployments in other countries. This is just from the GogDB statistics. It's growing partially because of the cream CEs are migrating over to the ARC6. ARC is suitable both for the large experiments like the WRCG, but we also recently experiencing interest from smaller research collaborations. So we believe that if you need a small IT infrastructure for scientific computing, then you can build it around an ARC product, where the ARC6 is one of the central components. This slide is just a summary of how ARC is integrated with the WRCG for those who are working in WRCG. So ARC is very well known for the WSCG experiment framework. So all the frameworks, experimental toolkits know how to submit jobs and how to manage jobs on an ARC6. So if you belong to one of those experiments like Atlas, CMS, so on, then moving over to ARC6 is almost straightforward from the experiment point of view. It is well integrated with the infrastructure services like Apple, Argus, BDI, GogDB, WOMS, and all the other monitoring components and the procedures. And ARC can be deployed both on restricted HPCs or opportunistic clusters like Boeing clusters, and of course on normal clusters. So ARC6 covers all the spectrum of the computing clusters of various kinds. This is a figure of the HPC deployment, and this is a high-level overview of Boeing internals. This is an overview slide of the ARC computing element and then the infrastructure ecosystem around. So let's start with the infrastructure ecosystems. These are ARC-based or NodeGit or ARC-based services which can integrate or can nicely complement an ARC computing element. You don't need to have them, but if you have them, this makes your life easier. So on this slide, you don't see the EGI or WSCG type of infrastructure components. These are ARC NodeGit related components. So I'm going to talk more about the ARC6, but let's first just a couple of words about these ARC infrastructure services, because very few people are aware that these things actually exist. So we got an ACT, which is a workflow management engine for the ARC jobs running on ARC6. Atlas is using this very much. We got an indexing service for the archery. This is an DNS embedded solution. We got a monitoring interface. It's kind of a nice web server pulling information from the computing elements. And then we get a service which can index the content of the data cache. These are the additional services. Then if we go down the actual ARC computing element itself, so the ARC computing element, the ARC6, is a couple of services what you install on a dedicated box on a front end. And then the computing element is communicating with the worker nodes through the batch system interfaces. So the cluster nodes communicating through the worker nodes through the batch system commands, the LRMS local resource management system commands. And in addition to the front end node, you can also have additional helper nodes which could help you with scaling up the data staging processes. So you can have a data staging farm in addition to the computing element front end. For the computing element, what you have there, internals on the boundaries, you can see the interfaces, the various interfaces. Quickly going through them. So we support SOAP. We're working on a REST interface. It's a technology preview being designed. And we have a grid FTP interface plus an LDAP interface. So these are the open public interfaces of an ARC6 element. You see the different operations, what you can do. One interesting thing is like the grid FTP interface we use to manage jobs as well. So creating jobs, canceling jobs that you can do through customized grid FTP interface. And then these interfaces can live parallel, so on the same front end. I don't want to go into details. You can look at this slide later for the internals. What is interesting here is that you get those data staging components in an ARC6, the cache, the data transfer service, which makes ARC very powerful when it comes to moving data to the front end or to the front end and from the front end to the worker nodes, and at the end staging data out from the worker nodes to the remote storage elements. Yeah, now on the next 6 slides, I'm going to give you 6 highlights of the ARC6. So why is it useful and interesting to go for ARC6? And the more technical details will come later by Henri and Florida. First of all, why is it good to go for ARC6? Because it's super easy to try the thing out. So if you have 6 minutes, then you can follow 6 steps and then have a functional ARC6 deployed and running for a simplistic jobs. It's very good if you want to try things out. But this is not that where it stops. If you want to make this temporary installations into a production setup, you can do it because based on this temporary setup, you can turn your system into production deployment using the same, starting from the same configuration. So from a zero configuration, where all the defaults are used, you can easily go over to a production configuration setup. And if you don't want to do it yourself, you can watch a video over in 6 minutes. Andre is demonstrating the 6 easy steps. So it really works. You can spend 6 minutes and start running jobs on ARC from zero. Of course, we don't recommend to use this setup for production, but for testing and have a quick overview of what the system is capable of doing. And the second argument why ARC6 is good for you, because the documentation is very, very detailed. We have technical notes, configuration descriptions, so you find everything there. Third argument for ARC6 is the data staging components. So if you ever had the problems like how you move data to the worker node and how you move data out to some experiment storage repository, then ARC6 is for you, because we got a clever system which takes care of data staging into the cluster and data staging out from the cluster. Plus, we got a cache on the front end where you can reuse files which are downloaded by and shared by various jobs. And we get many, many more other data-related components, various data indexing, so on. But just keep in mind, if your jobs are data intensive, sooner or later you will run into the problem of caching the data of the jobs. Then ARC has a built-in cache for this one. And then a new feature, ARCCTL, the ARC System Administration Control Tool. It's a one-stop shop to do all the many system administrations what you ever need to do with ARC. This is a very powerful toolkit. Andre will give you the details of this feature. So with ARC6, you only need to fire up ARCCTL, and then it does everything what you need as a system administrator. This is new. This was not available in ARC5. And then it's not very well known, but ARC is very powerful when it comes to protection against overloading of the front of the cluster, the front end. We got a lot of built-in resource protection parameters. So I listed only some of those. For example, with the max job parameter, you can limit the numbers of active jobs, the number of jobs doing data staging, number of jobs in a batch system, so on. So this is very nice feature that you can make sure that your cluster is not going to be overloaded by external job requests. And also, default DTL is a way to customize it, how long a job directory is kept after the job finished on your clusters. Plus, we get many other protections, overload protections, system resource limit parameters. This is not very well known, but this is a very powerful feature of ARC. You can control how many jobs you are actually entering into the cluster through the ARC6. A little bit more difficult part is the identity mapping feature. So a front end or interface or gateway from a local cluster to an external world always requires a component which is about mapping identity from the external world to the local cluster. And then in ARC, we provide a very powerful component for this one. This is the mapping feature. You can do mapping to a single user, mapping to pools. You can do mapping with RC maps. You can do mappings with traditional grid map files. A lot of things is available. It's very, very, very powerful. Yes. So anything what you were able to do with the CREAM and EGI setups, you can do very nicely with an ARC6 with the ARC native features. And then ARC6 also offers you customizability. So you could do very clever things with the state callout. So you could do things like, depending on what is the status of a job, you run a certain external commands, and then you can either reject, or you can do very clever things with this kind of state callout mechanism. Plus, we got something which is called the runtime environment framework, which gives you a possibility to customize the experiment of software environments available on the worker nodes. Yes. And then a traceability 6 plus feature. As a sysadmin, you can really monitor that what the job was doing and all the steps. You can check that, first of all, how much data, the input data the certain job was downloading. So the system has a full control over what the jobs are doing on the front end and on the cluster. So when it comes to development plans, so I said ARC is a very reliable pumped Volvo car. With the new features, with the new releases coming a year from now, maybe 2 years from now, we're looking into areas like we definitely will introduce a RESTful interface in production. We may develop dedicated data services, data transfer services for ARC, and we may go to ARC computing elements which will not require LLMS as an underlying service. Yep, and if you want to deploy ARC in 6 steps, what you need to do is follow this guide on the web page, and I just listed the quick 6 steps what you need to do. So you need to enable a software repository so that the ARC packages will be available. Then after the installation of the ARC packages, then you install the second step, one of the central components, the ARC. This is the computing element, the name of the computing element. Then you can run the ARC, and then you can generate with this toolkit user certificate and keys for testing. So you don't need to request certificate from your trusted CAs for testing. You can do it with the ARC packages what you get when you download or install ARC. And then as a 5th step, you can already start submitting jobs and checking the output. And then you can play a lot with other things like the system administration side monitoring. And all these ones are demonstrated in this short 6-minute video, but you can watch and repeat the steps. So that was it basically. And on this last slide, I summarized the essentials, what you need to know, like where you get the source code if you're interested, the binary packages from the various repositories, documentation, which is very detailed, and the various support channels. We have a Skype support channel where you can just join and then ask questions. And we get the more traditional email lists, and then the Gigas and the Bugzilla tickets also attended. Thank you. And then with this one, I ask Florido to continue with the changes to ARC6 from ARC5.
Hello, everyone. I am Florido. I am an information system developer for ARC. Let me see if I can share my screen with this old thing. Yeah. So if you have had worked with LDAP for ARC5, you probably have to blame me for things that were not working. So let me see. I think you should see my screen.
Yes, works.
All right, so I will go through a summary of changes of differences between ARC5 and ARC6. I try to be short, and I mean, this presentation is done from the perspective of operations mostly. It doesn't really go into technical details what we changed. There will be some of it here and there, but the first thing I have to say that probably you already know, ARC5 came to its end of life as of June 2020. This note I reported here on this slide is what is written in the NordoGrid website. So we kept providing security fixes until June, but now we will stop any kind of development or improvement on ARC5. So if any of you is running ARC5, you should already stop and plan for ARC6.
Can you please go to full screen? Or...
do you see the only part of my screen?
I don't see you. No, better. No, it's good. It's good.
Okay, there must be some problem with the update. So let me know if it's not good. So yeah, if you want to know more details about ARC6 and our releases, you just go to NordoGrid web pages. These releases site. I don't know if you see the pointer. Do you see it?
Yes.
Yes.
Okay, good. So I will start with the abandoned components. So this is things that were in ARC5 and we decided to remove from ARC6, so they will not be there any longer. One of those is a thing called Edges, which was an LDAP-based index service for discovering ARC-CEs. And this has been completely removed, except for the clients that can still, ARC6 clients can still search into it for backward compatibility, but otherwise we do not support it. And with it, we do not support all the configuration items that were in our configuration before. We replaced this service with something called Archery. I'll come back to that later, which is DNS based instead of LDAP. So for the index, no more LDAP. Then what another thing that we did is to clean up some endpoint and protocols. In ARC5, we supported a lot of different interfaces. And in the end, the code became very cluttered. So we decided to remove all of these and make the code easier to debug and control. Then we go to deprecated components. These are components that are present in ARC6. They were also in ARC5. But we plan to remove them in the next release after ARC6. We call it ARC7 now. So the idea is that you keep using these components if you cannot avoid, but if you can avoid, then you should go towards other components instead that we suggest. So these are, for example, the glue1 and NordoGrid information schema. This was used by many WSG experiments. I think it's still used, unfortunately, but while we were carrying on the work on ARC6, we actually cooperated with the experiments in order to make our glue2 rendering experiment friendly. So we recommend to use and enable glue2. It is actually enabled by default, so you have to actively disable it if you don't want it. It works with both web services and LDAP. Then the other thing that we're trying to put out is the grid FTP job submission interface. There has been a lot of discussion within WSG as well on how what it means to keep this interface. We know that it's still in use by most experiments, and Balazs showed that we still support it, but we think it should be not used in the future. And last but not least, we had in the grid world, we had these grid map files for authentications, and we are deprecating them. These were files containing the DNs of users that are allowed. There are many reasons why this is not a good practice to keep DNS of people in the folders of your system. So we provided alternative solutions for this. There was a small utility that was called NordoGridMap that was used to generate these grid map files. This utility is still present in ARC6, but we think if you sort out if you don't use any more grid map files, then you should also not use this NordoGridMap utility. And it also cleans a little bit your ARCconf, so the ARC configuration file. And let's go to improvements now. So I think the biggest and greatest improvement that we did is to rewrite the configuration almost completely. This means if you are still running ARC5, that your ARC5 configuration will not work with ARC6. As Balazs suggested, you need to send it to us and we will help you reshaping it for ARC6. That's the fastest way. We deliberately decided not to write any tool to do this conversion because we realized that ARC5 configuration was full of legacy things that people copied over that should be removed. So we thought it was better for us to investigate what kind of common mistakes were done during the ARC5 time by doing the conversion manually. The way you write the configuration, you can follow that link that I put in these slides. I will have another small slide about the configuration, but for now I go on with this. So we have a new form of runtime environments. Runtime environments are a way to provide computing environment for different applications. In ARC5, they demanded you to have this runtime environments also on the worker nodes, but we decided not to do this any longer. So these are mainly some bash submission scripts. So they can be also more complicated than that. But what we do now is that the code that say creates the environment for the jobs to work is embedded in submission scripts. So now you don't need any longer for the worker nodes to be able to see these RTs. A list of details is in the link I added in the slides. Then another great thing is accounting. We did the complete redesign, let's say, on while we were developing ARC6. In fact, I believe, maybe I didn't write it here, but many of the changes, the important changes came after ARC6.4 or came with ARC6.4. I think Andrew will elaborate more about it, but I think if you have a database of records from ARC5, you need to migrate it somewhat. And we will help you doing that if it's needed. Another big change is documentation. We used to have a lot of PDFs, but now we have everything online, and you can browse it online and search for things. And this helped also us to do support, because we can send you links to important parts of the documentation instead. Then last but not least, we tried to make performance better. We knew that there were problems with the number of jobs in several cases, and now we have an engine that is event driven. Instead of polling the list of jobs, it will just act when a job changes its state. As I said, I will not go into technical details in this presentation. So when it comes to new things that were not in ARC5, well, we have this zero-conf setup that in ARC5 was not so easy to achieve for the complexity of subsystems, and Balazs already spoke about it, so I will not go through it. We have this new index discovery index for CEs that is called Archery, and it's DNS based. You do not need to have any configuration in ARC.conf for it. It's all handled by the DNS system. So if you want details about it, I will not go through it, but there is a documentation page for it, how you set up this kind of thing. And then we have this tool, ARCCTL, that is basically used to control everything about the computing element and things around it. And Andre has a presentation about it, so he will detail it more. With ARC6, we distribute some RTs that we realize very important for every project and for every maybe future use. So the project ones are this M proxy that shares the proxy with the worker nodes when it's needed. And then we introduce some new ones, like some that I use to enable your singularity setup if you are using singularity on the computing element or in the cluster. And then we have some new technology. We always have technology previews in a version of ARC that kind of we use to test if the as a proof of concept. And this is this REST interface that Balazs spoke about. If you want to play with it, you can, but it at the moment is not suitable for production. But it's a good way for us to improve before we release the next release, if you help us testing it. So coming back to the configuration, I wanted to say a few things about how we improved it. And the idea mainly was that everything that you add in the configuration must have a clear connection with what you want to enable in the cluster in the CE. So we kept this INI-inspired syntax, but I have to make a statement here that is not exactly INI compliant. So many people try to do things that one usually would do with INI. It has some slightly different things. For example, we don't accept quotes, and then we don't accept comments in line, things like that. But you will see that we managed to be robust and consistent across all the configuration items. So the syntax is just one, and it's always that one. The defaults now are explicitly documented. In the past, we had no good way of doing that. And now basically all the subsystems in ARC, they take the defaults from the same place. So there are no inconsistencies that we saw in ARC5. We have this approach of config block enabled functionalities. That means if you write a config block in the configuration, it means that you as a sysadmin want that functionality to be there and work. And here I made an example. If you want an LDAP subsystem that publishes information, then you add the block infosys/LDAP. That means, okay, now I want the LDAP information. And what typically happens is that ARC will pick the default setup, the default settings for this kind of subsystem, and it will set it up for you. Then you can later change and add other options for customizing it. We have configuration validation at service startup. So if there are obvious mistakes in the configuration, the service will not start and tell you what is the problem, and try to hint at what can be the solution. We have, as Balazs said, a new authentication, authorization, and Unix ID mapping way of configuring these three things. In the past, it was a bit hard to understand, and we think that now we did much better. I will have an example right after this slide. We have a dedicated block for batch systems configuration. Before we didn't have. It was like not really well differentiated. Now you can have per queue authorization, which was not possible in ARC5. And then we simplified the accounting option parts, which was very hard to configure in ARC5. So just to give you a quick example of how we do authorization and authentication, here I took this example in which one wants to accept members of the Atlas virtual organization to access the CE. So the first thing that you do is that you create a group of users. Here we call it Atlas users with this outgroup block. And then you say, I want these users to be those that are members of the Atlas VOMs in all roles. And this will basically create a list of the ends of users that are allowed by Atlas. Then with the mapping block, you can decide that all the members of the Atlas group will be running in the cluster with user Atlas01. And then in the end, so up to here, we just did our authentication. Then when you want to authorize them to run, Balazs said that we have two interfaces, main interfaces. One is the grid FTP one, and one is the WS Web Service ARC native interface. To allow them to run, you put this string here, allow access, and then the name of the group that you want to allow. So I think, yeah, that's for how we do authorization and authentication in ARC6. So just as two final remarks, we changed the way we code on ARC. Now we have Git and we have continuous integration. This helped us a lot in identifying problems before we release. Of course, it's not perfect, but it's going much better. We have a different release scheme in which the bug fixes will come with a new minor release. And since this is an open source project, we are really happy for you to contribute to the code base if you want. If you can suggest changes that you think are better for your setup, and we will evaluate if these are good in for the release. And I mean, you can yourself become an ARC developer if you want. So coming back to the 6 points, if you are migrating from ARC6 to from ARC5 to ARC6, there are 6 things you have to do. The first one is that you rewrite your ARC.conf, which means you just send your ARC5 to us, or probably many of you just had Cream and never had ARC. Maybe we can discuss what are the important things in ARC.conf that go, but I can tell you that the try ARC6 video that Balazs spoke about is already enough for you to understand which are the main components. Then after that, you learn what are the ARC6 packages and service names. Then you get familiar with the ARC tool. Andrew would give us an overview now. You enable the important runtime environments that are required for your workflow. And then you need to learn the accounting subsystem changes. And the 6th step, if you want to be part of the index, is new DNS archery system, and you need to interact with us to enable this archery thing. Yeah, support. I mean, this is more or less the same that Balazs had, so I will not go through it. So I think I will give the word to the next speaker now, which is Andrew, I believe.
Yep. Let me share my screen. It sounds like I can't. Yeah, it looks like I have a technical problem with sharing. So Balazs, could you please share the presentation and I will just talk, because unfortunately I don't have an option to share screen now.
I can see if I can do it maybe.
Yeah, or yeah.
Is it a Zoom issue?
I don't know. So when I click, that wasn't happened before, but now I click share screen and see nothing.
To explore yeah, because when I last time opened on this, it was broken on my screen.
I should have it somewhere. Let me see. Here it is. I wonder if it works. Let's see.
Yeah, at least now I see it.
Just tell me when to change slide.
Okay, yeah, good. Thanks. So hi everyone. So let's go through the sysadmin toolbox and then we continue with the resource usage analysis as it comes in ARC6, the latest release of ARC6. As Florida already mentioned, the accounting changes was sort of in the middle of 6 release series, and for that one Unix 6.4. But in ARC, you don't care about the previous releases actually, so you should have the latest one because it contains a lot of bug fixes as well. So yeah, and we already have the latest available in all repositories. So let's start with the sysadmin toolbox, is it called? It's the ARCCTL or ARC control tool is a new interface that was introduced in ARC6. And the reason for behind it is just a way how it was in ARC5. In ARC5, there was a lot of location where you should look into if you want to troubleshoot CE, if you want to start CE, or even discover what's going on, which user is mapped to where, and whatever questions you have on the what jobs are doing on your CE. And now all this information is under your hand, so it is all possible to do with only one command. It is modular, and the modules are extending as well. So recently in the upcoming release, we extended a bit the data staging part as well. So you now have a lot information about data staging, for example. The major areas are the service control, the deployment automation, not only ARC, but the third-party components as well. So you can have deployment of CA certificates and whatsoever. Of course, it's a job control from the point of view of front end. You can kill, you show information about what is running, who is running, and where is running. You can customize and operate the worker nodes environment, and you can also do the configuration management in terms of getting inline help, getting overview of configuration, validate configuration, etc. And yeah, one major area is new as it is accounting. So you can have detailed information using the ARCCTL about what resources are being used. Let's go further. Yeah, so the highlights are single entry point, as already mentioned several times. I hope it's really easy to use because it hides the ARC6 internals, it hides the structure of the control directory, for example, that was previously necessary to know how it looks like in ARC5 to be able to operate and troubleshoot our computing elements. And it provides a lot of shortcuts. So even if you knew how to do it with ARCCTL, you can do it much faster. And it was designed initially with a bash completion in mind. It's very helpful to install ARC complete for your shell, and you can get the real advantage of completion of almost everything, like names of the users, job IDs, etc. Now, starting from the recent releases like 6.6, as far as I remember, you can use ARCCTL or subset functionality of ARCCTL as a standalone. So you can just install Node-agreed ARCCTL from whatever you want. It can be even enterprise extra packages for enterprise Linux, for example. You don't need even Node-agreed repository for it, and use it for installing even client certificates or WOMSs for clients. So it's very useful not only in the computing element world, but in general grid toolkit. Let's go further. Yeah. So let's start with all these 6 steps, continue with this from the perspective of ARCCTL, what is able to do for you. So after you install the main package, you actually can do everything else just with ARCCTL. So you need trusted certificate authorities. Okay, we have third-party deployment functionality, and you can ARCCTL deploy just with one command. If you're using WOMS, and in WLCG you typically use WOMS, you need a list of certificates or trust chains from the WOMS world, and this is also automated by ARCCTL. You shouldn't care about where to download it and where to find it, so it's works from you. So this is an example of a good shortcuts you can use to automate your operating. Modifying ARCConf, in this sense, you of course editing configuration file in your favorite editor. It is Vim, I suppose, yes. And you can, with ARCCTL in this sense, get inline help and validate our configuration as well. After you finishing the ARC configuration, the ARC control tool do some magic that is sort of discover which functionality you want to enable, getting into account the blocks you put into the ARCConf, and based on this configuration, it's capable to generate firewall rules for the ARC-CE and enable and start as configured. So this command is sort of magical in the sense that it's automatically bring the necessary packages apart from the ARIX you already installed. If you enable, for example, grid FTP interface in your ARCConf and then run ARCCTL service started configured, it brings grid FTP package automatically. It brings your globus dependencies, and it starts grid FTP service as well. So it is sort of major automation part that hide even knowledge of which kind of packages and which kind of service names are used. So all you need to know is just block names according to the documentation. Okay, let's go further. After C is running, ARCCTL is of course very powerful on analyzing what is happening. Let's start with just analyzing configuration. So ARCCTL config subsystems allow you to dump configuration. This is very useful for troubleshooting because it's apart from you wrote from inside the ARCConf, for example, as Florida said, if you enable infosys/ldep, ARCCTL config dumps show all the configuration values, so default configuration values that are inside this block, so which configuration parameters are taken into account in the actual running CE. If you just want to find important paths, important directories or logs, the very useful stuff is ARCCTL config brief. It's shown on the right of the slide. So it's just list you all relevant directories as configured and log files, so you can read further information about what's happening. And you can, for writing config, we have a good online documentation. It's generated from the same source. So actually, you can use either online reference and just Google it, or you can use ARCCTL config describe, and it will get you the same information just in the text format in your shell. And of course, you can trigger the verify manually. So if you don't do it anyway, when you start service, the verify part will be there as well. But yeah, it's wise to do it in advance, yeah, to spot some errors. Next. Oh, we can talk a lot about runtime environments. It's a very dedicated topic, but we don't schedule any time for it for today. But the runtime environment framework is a really powerful stuff that to extend ARC6 functionality and to bring some new features or resource discovery to capable to, for example, announce some GPU availability, and of course pre-configure some experimental software. But in ARC6, RTEs are not just the scripts that you write manually, it is the entire frameworks that you can operate from the ARCCTL. We are providing ways to enable RTEs, and in this sense, enabled RTEs used to advertise functionality of the computing element, and of course, if requested by the user, it was embedded to the job script. But apart from the enabled RTEs, we also have default RTEs that are not advertised and just embedded to the job script for every job, and this is the way how you can customize the job script the way you like, the way you want. And we're also introducing the RTE parameters, so you can craft RTEs that can be usable for many kind of computing elements, many kind of installations, but for example, different only by the pass to some image or something like this. You can see the example for n singularity, and you can just provide the singularity image pass and enable this RT or make it even default. So in this example, the configurer and Singularity will use this SRV container CentOS 7 image for every job that run on your ARC6, so it will be done just transparently for end user. Let's go further. The jobs, of course, is essential part of any computing element. And with ARCCTL jobs, I will not spend many time to describing each options. You can do anything with job. So providing information, killing, using some statistics, cleaning, showing the logs, showing the scripts, showing the service logs. So you can a lot of ways how to do it. Let's go further. And we coming to the accounting part, let's start with this ARCCTL integration. ARCCTL is just an interface that can query the database. And actually you can ask ARC6 about any previous jobs that was there and any parameters, either one by one or aggregated statistics. So ARCCTL accounting starts as a general interface to get information about the numbers of any kinds for total amount of jobs or jobs belong to some user, some VO. Of course, there is a lot of filtering. Information about past jobs that was in the accounting record but already finished, because ARC apart from the accounting subsystems, with ARCCTL job functionality, you can operate only the jobs that currently running and currently in the system. With ARCCTL accounting, you can see what was this job and what kind of resources was used like half year ago. Full life cycle of the jobs is tracked, so where the job is submitted, where it passed to LRMS, when it finished, when it failed, so all events are recorded as well. And a part of this data transfer functionalities, it is very powerful in ARC. We have even recorded the data transfer statistics, so how much data is downloaded or uploaded by the job as well. So this is actually almost everything, and all this everything, yeah, go to this slide. We collected in so-called ARC accounting record. You can find the complete definition in the documentation what's inside, but in general it is like resources, but apart from the resources, it is the ownership, it is hardware that is used, it is the execution environment, including the runtime environment that was requested and executed, and of course it's all identifiers that we can find about the job, global, LRMS identifier, the queue, the endpoint that what used it. So any kind of such identity information is also there. Where it is stored in SQLite database on site. And this SQLite database, starting from the 6.4 release, is essential part of the ARC6 functionality, and it is populated without any connection to the publishing of this information further. So it is existing, this information is collected, and you can publish it even later. So if you decide to publish it somewhere, for example, to the Apple services of the EGI, so you can use it later. So it is independent on the publishing process. So we can split the collection part and publishing part. So now it is completely different parts that are separated compared to the ARC5 design of the accounting, for example. Let's go further. Yeah, so this database is growing approximately 10 megabytes per 5,000 jobs according to our measurements. We choose SQLite now because it doesn't require to set up and configure some dedicated database, and SQLite is scalable enough according to the measurements, and this scalability was tested on the database that was generated by means of conversion from the old archive of ARC5 EURA that hold 10 millions of jobs that archived during the 5 years. So it is some kind of proof that is scalable enough to keep it in the SQLite. Let's go further. Yeah, so the two parts, the collecting and publishing. The collecting is also very depends on the configuration you have. So there is three methods you can use for collect resource usage. Resource usage data is collected by batch system, if it's like a fallback method. If you want more precise measurements in terms of memory, CPU usage, we recommend to install the GNU Time tool on the worker node, and if it's available, it's automatically used, and GNU Time is measuring many additional metrics regarding the memory footprints that used by the job. And another alternative is to use ARCjob cgroup tools that can be installed as additional package on the worker nodes, and it will put the job into execution inside the dedicated cgroup, but this tool is a SETUID tool, so it can be subject to some concert by security policy of the local cluster, but it is even more precise than GNU Time because cgroups mechanism is meant to be used but for this kind of measurements by the kernel. And reporting of the usage record, so we keep information in the local database and then you can publish it. So publishing to the central services is another subsystem. It is another script, another configuration block in our comms that you can enable, and we can support multiple targets of SGAS and Apple types. So the records are compliant to the OGF standards or EMI car standards for the Apple, and also Apple summary and Apple sync formats that is available. Yeah, let's go next slide. This is a more technical details how it looks like. So it's a database in the center. There is also some files inside control tiers that is kind of internals where information is stored initially, and this accounting publishing models. Now it's Python models that is part of the entire framework of ARC control, and it is used by ARCCTL accounting subsystem and by the another script that called EURA-ng that is used to publish to SGAS or Apple. Yeah, let's go further. This is just an example how ARCCTL job info, accounting job info looks like. So without any further options, it shows you human readable description of what it is. So where job was submitted, who is the owner, which virtual organization it is, and much more information regarding the identifiers that was used. And on the next slide, you can see the resource usage metrics as well. So this is detailed information about used wall time, CPU time, etc., and the environment used, and auth tokens, that is essentially WOMS attributes for the WLCG. And if you want it machine readable instead of human readable, ARCCTL is capable to show you, for example, in JSON format, and all this can be reused further in your scripting and whatever. Next, this is more examples about the events that's stored in the database. It shows a timeline of the job execution starting from the accepted to the computing element and finished all over the downloading, uploading, and LRMS. And data staging statistics is on the right side of this slide. It shows you how much data was uploaded and downloaded, either by total stats or by detailed information, which exact URLs are used and which size and which speed it is for it. More examples can be found in the documentation. There is a dedicated page with a lot of complex sort of examples how to do it. For example, you can filter data by used runtime environment, or you filter it by queue and for users that the job is used. So there are a lot of options how to do it. The highlighted example is exactly what was shown on the previous slide of how much data was used by failed jobs from the Atlas view, so for the data staging. So this is also possible. And a few words about standalone ARCCTL. So if you just want to use, for example, client or set up any other services that is not part of the ARC computing element, you can use ARCCTL just to deploy the certificates or installing WOMS configuration for both services and WOMSes. And we implemented the integration with the EGI virtual organization database. So actually all information in the EGI virtual organization database can be fetched by ARCCTL and deployed on your host in the standard location. And the third part is a part of the standalone package is a self-signed certificate authority that was implemented for testing and development purposes. Yeah. So that's actually all. Thank you for your kind attention. And yeah, we can go further to the question sections.